Okay, so welcome to our Wednesday Zoom without students. First of all, the question on 4.7 number 3, that's a problem involving the cost function. So this was the given function, and the problem was to find the production level x that minimizes average cost. Well, average cost is cost divided by x. So I call that C bar, and I already computed that. I divided the cost function by x, divide each term by x. And then to find the minimum production level, the production level that minimizes average cost, we take the derivative and find the critical numbers. So we're going to set C prime of x equal to 0, or C prime of x doesn't exist. Now I went ahead and found the derivative and then wrote it as a single fraction without negative exponents. So a fraction is 0 when the numerator is 0, and that's when x is 50. We don't take negative 50 because negative production cost doesn't make sense in this case. And then the denominator is 0. That's where the cost function derivative doesn't exist. That's at x equals 0, but that's not in the domain because here's our average cost function here. The domain's got to be x greater than 0. So there's only one critical number, and that's 50. And I'll leave it to you to check that that gives you an actual minimum cost. There's a video that explains that shows that that's a minimum cost. Okay, L'Hopital's rule. L'Hopital's rule tells you if you get a limit that looks like plus or minus infinity over plus or minus infinity, or 0 over 0, you can find the limit by taking the derivative of the top and dividing by the derivative of the bottom. So this first problem is just to decide which functions you could actually use or which limits you could use L'Hopital's rule on. So the question is, do we get this or this? So looking at the first one, we get sine, as x goes to pi over 8. On top, you're going to get sine of pi over 8. I don't know what that is, but it's not 0. And then 0 on the bottom. So that's not a 0 over 0. So we cannot use L'Hopital's rule on that. The next one we could. On top, you're going to get 0. And on the bottom, you get ln of 1. ln of 1 is 0. That's good. The next one, you're going to get sine of 5 times pi over 5 is pi. So sine of pi is 0. And on the bottom, you get 0. So you could use L'Hopital's rule on that. And then for this one, on the bottom, you're going to get negative infinity. And on the top, as x goes to negative infinity, e to the negative x looks like that, but we're going this way. So we get infinity on top. So you could use L'Hopital's rule on that. All right, now let's use L'Hopital's rule. While I was in the parking lot at the vet office, I did some of these. My dog is still at the vet, by the way. I need to go back, but I'll talk you through what I did. So when I initially look at the limit, I see it's 0 over 0, so I can use L'Hopital's rule. So that's this LH here. And that equals the limit. I take the derivative of the top and divide by the derivative of the bottom. Don't use the quotient rule. All right, then you look at the limit that's left. Cosine of 0 is 1. So on top I get 7, on the bottom I get 9, and that's my answer, 7 over 9. Next one, you can't use L'Hopital's rule right away because it doesn't look like 0 over 0. So to make it look like 0 over 0, rewrite secant 7x as 1 over cosine 7x. So right here, I haven't done anything but rewrite the limit. Cosine on top, cosine on the bottom. Now, cosine of 3 pi over 2 and cosine of 7 pi over 2, those are both 0. So I have a 0 over 0, and I can use L'Hopital's rule. And so the derivative of cosine is negative. You pull out a 3, so you get negative 6 sine 3x on top, negative 7 sine 7x on the bottom. Now, as x goes to pi over 2, on top you get sine of 3 pi over 2. That's down here. So that's sine of 3 pi over 2 is negative 1. Negative 1 times negative 6 is 6. And then on the bottom, you also get negative 1 as sine of 7 pi over 2 is negative 1 times negative 7 is positive 7. So you get a positive 6 over 7 as your limit. Okay, next one, I thought it might confuse you because there are two variables, But just remember here, t is constant. So you could replace t with something like 5. And let's just make sure we can use L'Hopital's rule on this. As omega goes to 18, the top goes to cosine 18t minus cosine 18t, which is 0. 18 squared is 324, so we get 0 on the bottom. So this, we can use L'Hopital's rule. This is a limit as omega goes to 18. Derivative of the top is negative omega sine omega t. And then the derivative of cosine 18t is 0 because 18t is constant. On the bottom, 324 is constant, and so we get just negative 2 omega. Sorry, on the top, that's a mistake. It's not an omega that comes out, it's a t. T is the constant, not omega. Sorry about that. Didn't mean to scare you. Okay, so now I let omega equal 18, and I get negative t sine 18t over negative 36, which is t sine of 18t over 36. Okay, and then this one I thought might cause some problems because we haven't taken the derivative of a to the x in a while. The formula for the derivative of a constant to the x, unless it's e, d by dx of e to the x, of course, is e to the x. But if your base is something like 2, you have to use this formula. You get ln a times a to the x. And if it's not just x in the numerator, in the exponent, if it's some function of x, you have to use the chain rule. So the formula looks almost the same, except you multiply by a u prime. And we're going to need that in the denominator of this limit here. When we let x go to 1, we get ln of 1 on top, which is 0. And then 8 to the 0, ln of 1 is 0. So 8 to the 0 is 1. 1 minus 1 is 0. So this is 0 over 0. And we can use L'Hopital's rule. So limit as x goes to 1 of 1 over x over, now I'm going to use that formula on this, ln 8, the derivative of the u of x is ln x, so 1 over x, and then 8 to the ln x minus 1. All right, now I can plug in 1. I don't even need to simplify. I could just plug in 1, and I'm going to get 1 over ln 8. 1 over 1 is 1. Ln of 1 is 0, so 8 to the 0 is 1. And then minus 1, so 1 over ln 8 minus 1. Okay, and then the last one I thought might cause some problems is the picture problem. This is the tangent line of the function at 0, and the slope of that line, you can read right off of it. The slope is 3, and we're going to need that. If we take the limit as x goes to 0 of f of x over x, we get f of 0 over 0. But f of 0 is 0, because that function goes through the origin. So we can use L'Hopital's rule. So by L'Hop, this is the limit as x goes to 0 of, take the derivative of the top, f prime of x, divide by the derivative of the bottom. Now if you put in 0, you get f prime of 0 over 1. Well, f prime of 0 is the slope of the tangent at 0. That's 3. 3 over 1 is 3. Do the same thing with the second limit. If we just take the limit, we get f of 0, which is 0, over 3 e to the 0 minus 3. That's 0 over 0. So we use L'Hopital's rule. This is the limit as x goes to 0. Derivative of the top is f prime of x. Derivative of the bottom is 3 e to the x. Now, let x equal 0. We get f prime of 0 over 3, which is 3 over 3, which is 1. Okay, 410 is antiderivative. So you're going to have to memorize this integral Bible for the rest of the semester, so you may as well get used to it now. It's not just memorization. This is just taking a derivative backwards. So, for example, the derivative of e to the kx, if k is constant, is k e to the kx. So this formula makes sense. The integral of e to the kx is the set of antiderivatives. So integral of e to the kx is 1 over k e to the kx plus c. The check is take the derivative of this and do you get the integrand, which is the thing you're integrating. So when you take the derivative of this, do you get this? And yes, because when you take a derivative, the k will come down, and that's why you have that 1 over k there to cancel. So these are a set of antiderivatives. So it's not just memorization, part of it's logic. Okay, so here, let's just do some problems. The rule you're going to use the most in this section is the power rule. The integral of x to the n is 1 over n plus 1, x to the n plus 1 plus c. So for example, the integral of x squared, you could do this in your head without using that formula. What function has derivative x squared? It's 1/3 x cubed plus c. Because when you take the derivative, the 3 comes down and the new exponent is 2. So that's the rule we're going to use the most. This first one, before you can use that rule, you got to clean it up. So this is going to be the integral of x squared plus 4x minus 12 dx. Okay, and now we can integrate each piece separately. The integral of x squared is 1/3 x cubed. The integral of x is x to the 1, so 1/2 x squared, but a half times 4 is 2, so 2x squared. And then the integral of 12 is 12x, because the derivative of 12x is 12, and then plus c. So there's your antiderivative. How do you check it? Take the derivative of this. If you get this, then you did it right. Okay, and you can see just mentally, you take the derivative of each piece there, you can see that it's going to work. Okay, they get harder though. Find the general antiderivative of this. So that means, another way of saying that, aka find this, the integral of negative 6x squared plus 4 over x minus, all right, leave the 4 over x the way it is, because that has its own special rule in the Bible. The integral of 1 over x is ln of the absolute value of x. All right, so that has its own special rule. But we're going to need the power rule on 5 over x to the 4, so we have to rewrite it as 5x to the negative 4, so we can use the power rule. Same thing with 3 root x, we have to write it as 3x to the 1/2. Okay, and so this is going to be, add 1 to 2, you get 3. Negative 6 over 3 is negative 2, so negative 2x cubed, plus, think of this as 4 times 1 over x. The integral of 1 over x is ln of the absolute value of x, and the 4 is a constant, so it multiplies along. And then add 1 to negative 4 to get negative 3. Multiply negative 5 by 1 over negative 3 to get positive 5/3 x to the negative 3. And then for this last piece, we add 1 to a half to get 3/2. 3 over 2/3 is 3 times 3 over 2. Sorry, let me do that again. So add 1 to get 3/2. 1 over 3/2 is 2/3. So I have 3 divided by 3/2, which is 3 over 1 times 2 over 3, which is 2. So plus 2x to the 3/2 plus c. All right. And then the last one I wanted to do with you is question 5. This is called an initial value problem. Let big F be the antiderivative of little f. So find big F, but we're given information that big F of 0 is 0. So first of all, let's just find big F. Step 1, big F of t is the integral of little f. Okay, and so now you can use the Bible, or you can just think, well, what function has derivative secant squared? That's tangent. So 2 tangent t minus, this is a 3 here, so we add 1 to get 4. 5 over 4, sorry, 10 over 4 is 5 halves, t to the fourth plus c. So that's step 1. Now we know f up to a constant. So step 2, find c using big F of 0 is 0. So 0 equals 2 tangent 0. Tangent of 0 is 0. This is 0 minus 0 plus c. So c is 0. Step 3 is to put steps 1 and 2 together. Take whatever you found for c and plug it back in here so that your answer is a function. Big F of t is 2 tangent t minus 5 halves t to the fourth plus c, but c is 0. So that's your final answer. Okay, and so that's all the problems I wanted to do. I will have office hours at noon on Friday, so if I don't see you then remember our midterm is on Monday, and I'll see you either Friday or Monday.